And welcome in my party people to part one of distance, rate, and time, where today our main focus is going to be hammering down the basics of distance, rate, and time. Now, before we started the recording, I talked to the live group here about, hey, where's our comfortability with the formula? Do we recognize certain things in word problems? And more importantly, what do we do when it's not just one distance or one rate or one time? So that's what today is going to be all about, really getting the basics down. So number one, we're going to learn how that formula works. That's the first and foremost thing we're going to do. Number two, we're then going to practice solving for each component. So solving for the distance, solving for the rate, and solving for the time. And I'm going to ask the question again, who here struggles to be confident with knowing if they're going to be multiplying or dividing in a distance, rate, time problem? Yeah, so just to prove the point, there were a ton of us feeling the same way. So this is going to be something that we're really going to hammer down today. Even if you've been to one of these classes before, I have a nice little way of thinking about solving for distance, rate, or time that should ease your practice just a little bit. And then number three, after we get the formula down, after we practice solving for each component, then we're going to be looking at those situations where, hey, what if we have more of one component? Like two distances or two rates or two times. I know a lot of us here recognize those types of questions on the test, but really struggle to understand what we're supposed to do. So if that's how you feel, then this is going to be a great class for you. So let's go ahead and get into the main notes here. So number one, we have the distance, rate, and time formula. Distance equals rate times time. But I also have, like I said and promised, a way to think about solving for the rate and time specifically. So before I put on a timer to let you go ahead and write things down, don't worry, I'm going to give you time for that. So put your pencils down. Let me go ahead and ask you this. My party people, when we look at distance, let me zoom on in for that. When we're trying to get distance, everybody, do we see with our eyes that if we're trying to get distance, what we're doing is multiplication? Rate times time. Who here sees that? Right on, right? We have eyes. We can definitely see that. Distance equals the rate and the time multiplied together. Perfect, perfect, perfect. Now, let me go ahead and just subtly help you think about it the other way. Everybody, real quick, let me go ahead and say we have a very familiar equation. Let's say we have 2x equals 10. This is just a random thought I had, a random equation that I wrote down. But everybody, take a look. Notice that we're not trying to, get whatever's on the other side by itself. We already have that. That's odd. We're trying to get x here by itself. Everybody, if we're trying to not multiply to get the result, but work backwards to get the variable by itself, what's that operation that we're going to do? What's the opposite of multiplication? Yes, that's going to be division. Absolutely 100% going to be division. So my party people, check this out. I would divide by 2 on both sides here. And if you would be so kind as to remind me what 10 divided by 2 is, help me out, everybody. Yeah, that'd be 5. Appreciate y'all. So that would be x equals 5. So the point of this wasn't to test out and see if we can do and solve 2x equals 10. No, that was not the point. The point was imitating the exact same thing that you would do if you were trying to work backwards over here. Because everybody, you're not always going to be given the distance. Sometimes you're going to be trying to solve for, let's go ahead and say, the time or even the rate. But everybody, check it out. Check it out over here. If I'm trying to get the t by itself, even though this isn't a number like 2, my party people, what am I supposed to do here if I'm trying to get rid of the r? If I'm trying to get rid of the r next to the t, if I'm trying to get rid of this, what operation am I going to do? Take a look at what you see and do the opposite. Yeah, notice that we're currently multiplying r times t. That's what we currently see. So to get rid of r, Yeah, we're working backwards. And so what we would do is divide both sides by r. It would end up canceling out. And notice what this says, everybody. Everybody, can we confirm with our eyes that that says d divided by r, distance divided by rate? Can we confirm that? Yeah, that's d divided by r. That is distance divided by rate. Everybody, check it out. This is all I'm saying here in the notes. If we're trying to solve for the rate, well, guess what? Let me just move this away right over here. Notice, if we're trying to get the distance, we just multiply, we're done. Distance equals rate multiplied by time. Just multiply rate times time and you have d. But if you're trying to work backwards, everybody, if you're trying to solve for, let's say, the rate, well then you would divide both sides by the time. So distance divided by time. And same thing, if you're trying to solve for time, you would divide both sides by the rate. So long story short, everybody, this is what you want to write down in your notes. Essentially, if you're trying to find distance, you're multiplying. If you're trying to find the rate or the time, you are dividing. My party people, does that make a little bit of sense before I put the timer up to let you take your notes? So one way is working forward. To get distance, you multiply. If you're trying to work backwards to get the R or the T, the rate or the time, you work backwards, and the opposite of multiplication is division. Now, I know seeing it in the pure algebra math way, I know that's going to be a little weird, for sure, I agree. But when it comes to showing this in practice, you're going to see much better how this is going to make sense. So here's what we're going to do. Let me put this timer up on the screen right here at the bottom right. I'm going to set a timer here for a minute and a half. I'll just go ahead and say 2 minutes just to be a little loose with the time there. But I want everybody to go ahead and write these notes down. And once you are done, just type ready in the chat box and we'll go ahead and move forward once the timer is done. All right, let's go ahead and move forward here. So we have our notes. We wrote them down, but now let's go ahead and put things to the test to really understand, hey, how do we point things out? How do we actually go ahead and solve a problem? As small as it might be or as big as it might be, how do we solve it? So let's go ahead and move forward here to the first example problem. Now notice we have stripped this of A, B, C, and D. No multiple choice, just right here, a flat, straightforward, fundamental example. And don't worry, for those of us that really have that itch to be tortured, or have a lot of fun with math, we're going to go ahead and up the difficulty in just a couple of questions. But let's go ahead and start here with the fundamentals. So regardless of how easy or hard a question might be, everybody, pop quiz, what is the first thing we do? Yeah, Jasmine was already there. Yeah, read the question. That's the first thing we want to do. So right over here, here's what that means. How far does the cyclist travel in 5 hours? I'm not talking about reading everything from start to finish. No, I'm not talking about reading the entire problem. No, I'm talking about reading the question first. Because everybody, when we read the phrase, how far, what does that mean to you, my party people? When we say, how far did someone travel? What does that make you think? From the 3 main things that we're talking about today, distance, rate, and time, which of those does it sound like? Yeah, it's distance all the way. Yeah. How far from point A to point B? Could be feet, miles, kilometers, but yeah, we're talking about distance. Great job so far. So that's what we're looking for. I want to write that down. I'm looking for the distance. Now, in that same sentence though, it might be confusing to see the word hours, but everybody, can we all agree real quick that when they say 5 hours, this is just conditional information that they give you, not what you're looking for, but information that they give you. Awesome. And I'm going to be repeating that. I got you for sure. So everyone, I know this might be the most obvious question I might ask today, but I still need to ask it. Everybody, we're looking for distance, that's true, But 5 hours, which idea does that fall under? Distance, rate, or time? Correct. That's going to be time. Appreciate y'all. Thanks for humoring that. So there we are. So the time that we're given is 5 hours. Now, let's go ahead and read the rest of the problem here, everybody. But before we do, I want to do another pop quiz here. I really want to push your understanding. Everybody, if we're looking for the distance and they gave us the time already, which of these ideas do we need to find to be able to solve for the distance? Which of these ideas do we need to have in order to proceed? Yes, that's going to be the rate all day. So my party people, do you see how I just did that? Do you see how I can predict that, yeah, look, I'm going to need to find the rate if I expect myself to be able to plug things in to the distance equals rate times time formula? Do we see how I thought about that without actually having to look at the actual problem? Good. This is something that you want to do. As soon as you identify that you have a distance or a rate, you want to start thinking, where's that time? Or if you're looking for the distance and you have a time, you want to start thinking, how am I going to get that rate? So these are things you're going to want to do. And don't worry, I'm here every step of the way. I got you. So let's go ahead and figure out what that rate is going to be. What do we read? It says a cyclist rides at a steady speed of 12 miles per hour. All right, everybody. Now, I'm going to be straightforward. Yes, the 12 miles per hour is going to be the rate. But can anybody tell me what the one word that really gives it away is? What's that one word that gives it away that is a rate? Oh, yeah, it's the word per. The word per gives it away all day. Because, everybody, a rate is basically saying how far you go in a certain period of time. Again, how far you go in a certain period of time. So this is how far you go in 1 hour. When you are mixing distance and time, that is the rate. How quickly you travel that distance in what time frame. Before I continue, does everybody understand that the word per is really what gives it all away? Perfect. And again, just to reinforce that, if we are saying distance in this amount of time, so distance per time, or if we say, 7 miles every hour or per hour, whenever we're mixing those two units, that's how you know you're dealing with a rate. But now that we're here, let's see how easy this can be, everybody. We're looking for the distance. Let me highlight that right there. Everybody, do we have what we need to solve this? Do we have the rate and the time to plug in? Yep, we absolutely do. So let's go ahead and finish this up. Our rate, everybody hit me in the chat box. That's going to be perfect 12. And then what is the time that we're dealing with? That's going to be 5. Yep, there we go. So our distance equals 12 times 5. Not terrible. What's 12 times 5, everybody? And there we are. The distance for the first problem is 60 miles. And there we go. So just to play it through again while we wrap up taking our notes or our screenshots, I got you. So what we have here is we're looking for the distance. So we knew already that to get distance, you got to multiply rate times time. So this is actually how you could have known from the very beginning that, yeah, I'm multiplying in this case because that's how you get distance. You multiply the rate and the time together. Who here was able to kind of stay calm through that when we saw that we were looking for distance, or who pointed that out from the get-go? Right on. That's, again, another thing that you want to do. Analyzing before you take action, always a good thing. So analyzing, saying, hey, I'm looking for distance, so I know I'm going to be multiplying, right on. Now, when we talk about finding rate and time, pop quiz, what operation are we actually going to be doing? If we're trying to find rate and time, oh yeah, division. If we are going to work backwards to try to find the rate or the time, that will be division. So with that said, are we ready to move forward to the next practice problem? Sweet. Now here's what we're going to do, everybody. Very first step is this. The very first step is typing into the chat box what the goal is. So read the question first and tell me what the goal of the problem is. The distance, the rate, or the time. Go. 5 seconds. 4, 3, 2, 1. Submit your answers here. I'll give you 5 more seconds to submit it. 4, 3, 2, and there we go. Excellent job, everybody. That's what we need to do. First thing, as soon as we start a problem, boom, what's the goal? What do I care about? What am I supposed to find? And right there in the question sentence, it says, what is the speed of the train? Now, everybody, speed is another word for rate. Speed, how quickly you are moving. Rate, how quickly you are moving. So with that, we know for a fact that we are looking for rate. And everybody, because of that, what operation do we know we're going to do? Since we're not looking for distance, we're looking for the rate. Hey, there it is. Yeah, we know we're going to divide at some point to get the rate. So with that, let's write our formula out again. Distance equals rate times time. Right there, perfect. And then the rate is what we're looking for. So let's put a note here for the distance and a note for the time, and let's read. So a train travels at a constant speed for 3 hours. So everybody, I think we can all agree that that's going to be our time. The train travels for 3 hours. And then it covers what distance? It covers 180 miles. So not miles per hour, just miles. That's just a distance. If we would have said 180 miles per hour, that's a rate. But if it's just miles, just feet, just kilometers, that is a distance. Really reinforcing this for everybody out there, because I know some of us may have some questions about that, and I got you. So there we go. The distance is 180 miles. Everybody, do we have what we need here to solve this problem? Do we have enough? Yeah, I think so too, because we are looking for the rate. And remember, you can't solve this equation for the rate if you don't have the distance or the time. So we have the distance right here, and we have the time right there. So given that we have both of these and we're good, yeah, we're good. Let's plug and chug and we're done. Now this is where we can confirm that we're going to be dividing. I'm going to plug in the 180 for distance. I have my rate that I'm looking for, so I'll just leave it as R. And then we're multiplying by that time, which is going to be 3. So notice, I'm trying to get that rate all by itself. And again, to do that, my party people, I got to get rid of the 3. Everybody, we're multiplying by 3 here. And remember, to solve an equation, we're doing the opposite operation. The opposite of multiplication, that's going to be division. And that's where we'll see dividing by 3 on both sides. So that's how we know. We predicted it. We're looking for rate. We predicted division. And yes, indeed, that's how we're going to get the rate by itself with that division. 180 divided by 3, everybody. Right on. Yeah, that's going to give me 60. And there we go. 60 equals the rate. And everybody help me out. How do we write the rate again? 60 what? What are the units that we're going to write? If the distance was in miles and the time was in hours, how do we write the unit for the rate here? Ooh, man, y'all are sharp today. Let's go. Yep, 60 miles per hour. That is correct. And there we go. And there we go. Now, just 2 examples in. I already saw quite a few of those light bulb moments in the chat box. So just to go ahead and gather that sentiment one more time, are we feeling good about just, at least initially, with the difference between knowing when you're supposed to multiply versus divide? Good. I'm glad. Yeah, even a step in the right direction, even kind of, sort of, I'm seeing it. That is good, because guess what? We only did 2 examples so far. We got plenty to go, plenty more opportunities to really reinforce that confidence. I got you. Let's do the same thing one more time, everybody. I'm going to give you a few moments to take a screenshot of the question, finish taking your notes. But in the next problem, same thing. First thing you're going to do, is tell me what we want, what the goal of the question is. Read the question and tell me what we're looking for. Here we go. In 3, 2, 1. You have 10 total seconds to have your answer written down. 9, 8, 7, 6, 5, 4, 3, 2, and 1. That's excellent, everybody. This is what we want to do every single time. Point out what the goal is. If the driver covers 200 miles, we're not looking for distance, everybody. They gave us a distance, and y'all correctly ignored that. Perfect. Then it says, how long does the trip take? And when we ask how long something takes, we're thinking, hey, it could take 5 minutes, could take 5 hours. But that sounds like time. And there we go. So with that, booyah, we are looking for how long the trip takes, and that is time. Everybody, do we agree with that before we move forward? How long, meaning time. Good. Now, up next, let's do what we've been doing. As soon as we know what the goal is, let's take down the information. Again, step 1, what's the goal? Step 2, what do we have? And so when we read what we have, we see that it says 200 miles is what's covered by the driver. Everybody, what did I say that was again? The 200 miles represents what? Oh, yeah. That's going to be distance. Absolutely. So let's write that down right there. And then we see here a car moves at a constant speed of 50 miles per hour. Everybody, there are 2 words, 2 separate words that give it away. What's the first word that tells me that the 50 is the rate? What's the first one? Yup, exactly like I've been teaching you. The word per gives it away. Miles per hour, mixing those 2 units. For sure, that is a rate. Now, what's the second word that gives it away clearly in that same sentence? What's the other word that really gives it away? Jacob, shout out to you. Yes, that word is speed. So there's 2 things, 2 big clues that you can work off of, and then you just continue moving it from there. Speed and the word per, both of those give away rate. So let's write down right here. The rate is 50 miles per hour. Now, everybody, tell me, another pop quiz question. Because the distance is measured in miles, and the rate is also measured in miles per hour, but given the way that the rate is set up, miles per hour, how are we going to measure time? What's the unit for time based on what we have? What's the unit for time that we're going to be dealing with? What's the unit for time that I'm going to be dealing with? Not the operation. I see some of y'all are already ready for the for the operation. I see that. But yeah, it's going to be hours. You don't even have to, really look anywhere else other than the rate. Because again, it's distance per time. Hours is what we'll have. So just want to help you understand how to point out what units you're dealing with. Because everybody, has anybody here ever done a distance rate time question that was also a unit conversion problem? Yeah, so if you have, I'm sorry. And if you haven't, you're lucky. So with that, we'll talk about how to deal with these as we continue building our confidence up with this. But remember that topics can and will be mixed on this test. So let's go ahead and finish up here. Distance equals rate times time. We have the distance of 200 miles. We have the rate of 50 miles an hour. And we have that time sitting right there. Everybody, what operation are we going to do to finish this problem off? We're looking for the time, so we know we're going to, we're going to divide. Excellent job so far today, everybody. Yes, divide both sides by 50. And right there, 50. And we are good. The time here equals 200 divided by 50. 50 goes into 200 4 times. And we said, again, because it's miles per hour, it's going to be 4 hours. And there's our answer. Booyah. There we go. So I'll ask again, who here is feeling a little more confident in terms of knowing that when we're solving for rate or time, we'll be dividing? Excellent. Right on. All right, so let's go ahead here and push it to the next question here. So we have one more to go before we get into the meat and bones of today's class, which is going to be what happens if we have two of something, like two speeds or two times or two distances. What are we going to do, right? So here we go. Last question here. And the first thing I want you to do, as always, point out the goal. You have 5 seconds here. Go. Starting now. 5, 4, 3, 2, 1. Yes. Excellent job. The answer there is distance. Correct. Remember, this is a strategy to help get past test anxiety. Test anxiety is not like some light switch. Test anxiety is more like a spectrum that you can manage. You know, some of us may feel more anxious than others when it comes to math and testing and, the whole nine. But remember that there are things that you can do in your daily practice to make test anxiety a little more manageable and more manageable as you continue practicing. So here, the question is asking, how far has the boat traveled? And so when we're asking how far something travels, we can absolutely begin to think about distance. So great job, everybody. We're looking for distance right there. And now let's go ahead and assess the information that we have. So here in that same sentence, it says after 2 hours. So that's our time right there. No problem. Time equals 2 hours. There we go. Now up next, in that first sentence, we see that we have a boat moves down a river at 15 miles per hour. Everybody, what are we looking at with the 15 miles per hour? And how do we know? Come on, support your claim. Support that claim. Give me a reason. Prove yourself. Jaslyn, shout out. Yes. Deborah, yes. Perfect. Yep. Everybody else that's following suit. Yes. We're dealing with a rate because we see that it says miles per hour. Connecting the distance and the time together, that is the rate. So with that, booyah, we write that down nice and easy. Rate equals 15 miles per hour. And now we're ready to go. Distance equals rate times time. We are looking for distance, so I'll keep that right there. Everybody, just to make sure that we are cementing our confidence, we're looking for distance. So what do we know we're going to do operation-wise? We know that we're going to be multiplying. Remember, to get the distance, we are multiplying the rate and the time together. If we're looking for either the rate or the time, we're working backwards. But here, the distance is already by itself. No manipulation needed. Just straight up multiply the rate and the time together, nice and easy. So here we have the rate being 15 miles an hour, the time being 2 hours, everyone 15 multiplied by 2, 15 times 2. That's going to be 30 miles. And there we are. Boom. Nice and easy. No stress, because we're working off of understanding and not memorization. That's really going to be the big key. So, with that said, my party people, are we feeling like we have the basics, the essentials down? If we're trying to, if we're looking at one of these fundamental questions where they give you 2 of the 3 pieces, whether it's distance, rate, or time, you know what to do. You know if you're looking forward, you know if you're working backwards. Like, that's really going to be that level 1. And honestly, just to be very clear here, who's seen a question as easy as what we've seen so far? One question, not like the whole test, but who here has seen at least one question that was that straightforward? You're going to get a couple of those. So what you want to be prepared to do is to make the fundamental easy things look and feel easy. Because then when we move forward, to the moderate and challenging questions, then guess what? We are going to give ourselves more time to handle those. So with that, my party people, here's what I'm going to do. I am going to, and I swear, sometimes I joke around and I'm like, yeah, I'm going to go ahead and torture. I mean, fun. I know I try to mess around with you guys sometimes, but I'm going to be very real with you. I'm going to throw you to the wolves with this next problem. I'm going to put a 2-minute timer on the screen. Your goal is not to solve the entire problem in 2 minutes. Your goal is simply going to be telling me what it is that we're looking for. And then number 2, make a plan. Write down the information and have a plan. If you can actually talk about how you think we're supposed to get to the right answer, you are taking leaps in the right direction. My party people, are we ready to give the first one a shot? This next one, again, is going to be a different problem. It's not going to be as simple as here's 2, find the other. It's going to be a little different. All right, sounds good. I'm glad that we're ready. So let me go ahead and give a little bit more of a buffer here. So you have 2 minutes and 15 seconds technically. And here is the timer on the screen. And let's get started. Who here feels like they got a confident answer? Let's go ahead and try this one out. All right, let's go ahead and get after it. So even if we were confused, no worries at all. Again, we're here to see how far we can take it and then how much better we can get. That's what it's all about. That's what it's always been about. So here we go. First things first, everybody. What are we looking for? What's the goal? What is the goal? When we read the question, what is the goal? Yeah, we're looking for the distance. But more specifically, everybody, what's a key word that we noticed that's right there with the distance? Yeah, we're looking for the total distance right here. Look, what was the total distance traveled, everybody? What was the total distance traveled? Everybody, let's go ahead and just play pretend, go daydreaming for a second. If we said that, hey, in the morning, I went that far. In the afternoon, I went that far. What do we do to get the total distance on that day? If we're just hypothetically talking. Yeah, I think we can all agree we're going to be adding. If we're trying to find the total distance across a couple of events, 2 events, we're going to add the distances for each of those events. Now, let's go ahead and see the information here. So again, we're looking for that total distance. And what we notice is we're talking about a cyclist, and this cyclist rides at 15 miles an hour for 2 hours. And then, let me highlight that right there. And then at 10 miles an hour for 3 hours. Everyone, before I continue, do we notice that we have 2 events? 15 miles an hour for 2 hours, a rate and a time over here, and then a rate and a time over here. Sweet. That's really all we need to know. Because once we understand that, then we can say the total distance is the distance from the first event plus the distance from the second event. And when we try to figure out what that first distance was, remember that that's just going to be the rate times the time for that first situation. And I'll go ahead and highlight this so it's really easy to follow along with. I'll start with green here. Distance 1. We have the rate and the time right there. So even though they didn't give us the distances, we can find the distances. That's going to be the biggest thing there. Before I continue, do we all understand that? Even though we weren't given explicitly, like, hey, this is the exact distance, we can still find those distances because we know our formula. We can find the distance by taking the rate and taking the time and multiplying together. That's how we can actually find that distance. So it's like a little detour that we have to take, and it's necessary to get the information we need. So let's go ahead and figure this out. We have the rate and the time, so 15 miles per hour right there, multiplied by 2 hours right over here. Everybody, 15 times 2, what's that going to give us? Yeah, that'll give us 30. So there we are, the first distance that's going to be 30 miles. So we have that. That's our first distance. So we have what we need right here. We're good. But we're not done because we still need to find the distance for that second part of the trip. And so that's going to be right here, 10 miles an hour for 3 hours. So I'll go ahead and highlight that right there because we'll work that out right now. Again, we were not given the exact distance. We're given the rate, miles per hour, and we're given the time, hours. So with that said, even though they weren't gracious enough to just give us the distance, we have the wherewithal that we need to figure it out. We have the information. So here we are, distance 2, the second distance, that's going to be equal to the second rate times the second time, and that's right here. That's going to be the 10 multiplied by the 3, and that's going to give us 30 miles as well. So that's just a coincidence that there was both 30 miles. Maybe he was going to the beach and coming back, right? But that's neither here nor there. Because, everybody, the goal of the problem was to find that total distance, which was going to be found by multiplying the first distance and the second distance together. These two, we're going to add these together and we're done. So let's go ahead and get that done. Here we are. Let me move this over here. And let's solve. So we have 30 miles from the first distance plus 30 miles from the second distance. Everybody, hardest question of the day, 30 plus 30, what's that going to be? Yeah, that's going to be 60 miles, and we are done. That is our total distance. My party people, was this problem as bad as we thought it was going to be? Right? Not as bad as we thought. Not as bad as we thought. Now, what was the main reason for that? Because I think we can all agree that when we see new questions with unfamiliar ideas, it's very easy to get into that shell, right? Really easy to kind of back away and, try to guess or hope for the best. But what made this one different? Well, what made this one different was that the approach we took allowed us to see the information in a much better way. I'm going to say that one more time. The approach that we took allowed us to see things in the right way. So my party people, first step, as always, read the question first. Here it said total distance. We saw then that we had a first event in green and then a second event here in purple. Although we weren't given the exact distances for each, we can find the distances because we have that knowledge now. We have that information that says, if I want to find distance, I can multiply the rate and the time together. If I want to find the other distance, well, if I have the rate and the time, I can multiply them together. And once I found those distances, then boom, there's the first one, there's the second one, add them together to get that total. And to answer the question from the chat box, what do we write for both of the distances together? It's still going to be miles because we're just adding. It's like saying, hey, 1 foot plus 1 foot, that's just 2 feet. 6 inches plus 3 inches, that's 9 inches. 30 miles plus 30 miles, that's just 60 miles. So with that, everybody, who here feels nice, well, and confident about this first one that we did? Hey, let's go. All right, now here's what we're going to do next. We're going to actually circle back to the notes that we were taking right over here. And I'm going to talk to you about what we're going to be seeing in today's, today's main set, which is what we're doing right now. Because now we're talking about not just distance, rate, time. Now we're talking about, well, perhaps multiple legs, where we have more than one distance or more than one rate or more than one time. So I want us to go ahead and write this down here, but just wait a second. Let me just explain what you're looking at. So if we have trips with multiple legs, like we just saw, to get the total distance, remember what we did here. Let me highlight this in red. To find that total distance, remember that what we did was we found the separate distances first. the distance of the first leg, the distance of the second leg. If there's 3 legs, find the distance of the third leg. But to get the total distance, you find the individual distances first, then add them up together. Again, read here, multiple legs. We're not talking about 2 objects moving at the same time. Very different circumstance. Here we're talking about one person moving multiple times. Now, this, in my opinion, getting the total distance between this and the other 2 things that you could find, I think that the total distance is the most straightforward. Because to get the total distance, get the first distance and the second distance, add them together. Now, when it comes to finding the total time or the average speed for the trip, this is going to be slightly trickier. Now, the total time is pretty similar, but still a little tricky. Because if you want to find the total time, well, that's going to be straightforward. That's actually just going to be adding the time for each leg. That's going to be pretty straightforward relative to the next one. But again, to get the total time, let me highlight this in purple. We're going to be adding the time for the first leg and the second leg and however many legs you have and adding them all together. This last one though, everybody, to get the average speed for the whole trip, be very careful. Be very careful. Because adding the speed for the first trip and the second trip is not how it's going to work. To get the average speed, that's going to be your speed accounting the entirety of the trip. And to account for the entirety, you need the total distance divided by the total time. Again, if you want the average speed, so if we have distance equals rate times time, to get the rate for the entire trip, you need the distance for the entire trip and the time for the entire trip. This one right here, my party people, the average speed for the trip is the only one that's going to be solved differently because you need the totals, for the distance and the time first. Are we good on that, my party people? Sweet. So with that said, I'm going to put a quick timer here. Well, not quick, but I want you to write down everything here because, I wanted you to listen to me. So there's the timer on the screen, 3 minutes here. Just type ready when you're done. And once we're done with that, we're going straight into the next practice problem. Timer's up. Let's put that confidence to the test here. So next problem coming up here. Let's go ahead right here. Let's give it a shot. Same timer here, 3 minutes. So that way you have all the time that you need to calculate. There we go. Timer's up. And again, type ready when you're ready. Don't reveal those answers. All right. So with this problem, everybody, let's go ahead and begin the right way. What is it that we're looking for here, everybody? What is it that we're looking for here? Yeah, we're looking for distance. That's very good, very good. We see here that it says, what is the cyclist's final distance from the starting point? Okay, everybody. Now, sometimes we're creatures of habits. Everybody, who's been in that position before where the next question seems very similar to the previous question and you're almost inclined to do that question the exact same way that you did the last one? Yeah, that's a lot of yeses. Yeah, so here's what's going on. Remember that the test that we're preparing for, it's really about understanding the question, understanding the information, and formulating a solution. Now, we cannot assume that it's going to be done the same way every single time. Let's really think things through. I know the anxiety can force us to do things we don't want to do, but let's take it one step at a time, everybody. What does it say here? It says, what is the cyclist's what distance? What does it say? What is the cyclist's what distance? Yeah, final distance from the what? From the what? Yeah, from the starting point. So let's highlight that here. What is the cyclist's final distance from the starting point? So everybody, let's go ahead. when in doubt, let's draw it out. When in doubt, draw it out. So let's go ahead and say that we have a starting point. And let's call that starting point right here. Starting point. Then, remember, we're looking for that distance. We're looking for that final distance. Now, let's go ahead and read. It says, we have here a cyclist that rides 5 hours north at 12 miles per hour. So let's go ahead, zoom on in here. Everybody, north, if we're just drawing on this paper here, what direction should I draw north in? You know, if we're trying to behave like normal people, I guess. Yeah, we're going to be drawing up. So, okay, cool. So let's go ahead and draw that first part. We'll say north. Let's make that a straight line. Perfect. Boom. Now, everybody, when we headed north, when the cyclist headed north, what are those pieces of information that we were given? What were we given here? I see here that we're given 5 hours and 12 mph. What are those pieces of information? What are we going to categorize those as? Yeah, the 5 hours, that's going to be time. The 12 mph, that's going to be hour rate. Exactly. Perfect. So with that said, let's go ahead. We have ourselves, and I think you guys are right. There should be a quick correction. So we're going to call this one right here. This one is C. It was supposed to be C, but it was supposed to be 39. Looks like there was a quick little typo there. But we're going to talk about why C is the answer. I want to just address that there because I see y'all having the questions there. I got you. But here, so we are going north 5 hours at 12 miles per hour. So we have this. We have our time equals 5 hours. And then our rate is 12 miles per hour right there. Okay. Now, everybody, that's not even the most important part. The most important part is this next part here. It says, and then rides 3 hours south at 7 miles per hour. So, everybody, quick question. If we were going up for north, what direction are we going to be going for the south direction? Yeah, we're going to be going down. Exactly. We're going to be going down. So let me highlight that here in red. And actually not use red, let's use purple. And so rides south 3 hours at 7 miles per hour. So starting from here, going down 7 miles per hour, 3 hours. So before we continue, before we actually do any math at all, everybody, for those of us that believed that we should be adding, do we see that adding actually isn't the right way to go here if we are going to go north and then we're going to turn around coming back south? So again, I do humbly apologize for that quick typo here in the correct final answer. That's on me, for sure. But even with the typo, do we understand that we shouldn't have been adding? Because if we were adding, that means that we were looking for the total distance. That means that we were looking for the blue plus the purple. But what we're actually trying to do is trying to find the blue minus the purple. That's what we're trying to do. We're trying to find the distance from here back to the starting point. And that means we need to eliminate that right there. We got to eliminate what we crossed back on, what we turned around on, because all we care about really at the end of the day is this. This is what we care about. So my party people, do we understand that the right way to get the final answer is subtracting this distance that we went south from that distance that we went north? Hey, no worries if you had a brain fart. No worries. I saw someone put the word brain dead in that private message to me. You're not brain dead. You're good. But, this is what we want to do. We want to problem solve in the sense of, hey, what is the information saying? What is the story saying? So that's really the big part of this problem here. So with that, my party people, let's go ahead and from here, understand what the first distance was going north, then that distance going south, and then we'll subtract. And Eddie Risa, if you want to fight me, that's why I teach virtually. Good luck finding me. That's all I'll say. So here we go. Let's go ahead and get that distance. So here, that first distance, it's going to be the 12 miles an hour multiplied by the 5 hours. Everybody, what's 12 multiplied by 5? What's that going to be? Yeah, that's going to be 60. 60 what, everybody? Help me out. What's the actual unit? What are we supposed to have? 60 what? It's a distance, not a rate. It's a distance. Yeah, that's going to be miles. Exactly. Just miles. Because remember, miles per hour, that's rate. This is just 60 miles. There we are. So we have 60 miles. And that's the first distance. Now, let me erase the highlighting here so I can show you again why we're going to be subtracting. Because, everybody, let me go ahead and make it super straightforward here. Let's pretend that we're just taking steps. Everybody, if I took 10 steps forward and then 3 steps back, if I took 10 steps forward and then 3 steps back, where would I end up? Yeah, that would be 7. Because if we go forward 10 and then back 3, we take away the 3 that we went forward and backwards on. So it's just 7 steps from the starting point. That's exactly what is happening here. We go 60 miles north. Then here, the 7 times 3, that's 21. 7 times 3, that's going to be a distance of 21 miles. So what ends up happening is we go 60 miles up and then 21 miles down. And to get that distance from the starting point, we have to subtract for the same reason as if we took 10 steps forward and then 3 steps back. So does that part right there really make some more sense? Because, the numbers, the calculating, the typo, that can all be forgotten. But what's really going to establish that confidence is the reasons why. That's really going to be it. So going up or north 60 miles, then back south 21 miles, that tells us that we have to subtract to figure out where we are, the key word being the starting point. 60 minus 21, everybody, is going to be what? Yep, that's going to be 39. Let me go ahead and get in my time machine and tell myself earlier, hey, buddy, stop working through lunch and trying to do 2 things at the same time. So that's going to be here, 39 miles. Yep, so if you had C with a 29 or 39 and you caught the mistake, hey, more power to you for sure. So, with that said, my party people, with that, are we ready to try another one out? Where again, the problem could be completely different. It's really going to be a matter of, hey, what am I looking for? What is the problem saying that we have? What can I do? Right? Cool. So let's go ahead and try this next one out. Here we are. Let me put the timer on the screen. This one's going to be just 2.5 minutes. And again, everybody, we are here to try to reason with the problem. If you get to the calculation part, great. But I really just want you to get to what's the goal? And then from there, what can we do? If you can actually have time to calculate, great, but no worries. And let's give this problem a shot. So first things first, everybody, what is it that we are looking for? What are we looking for? Quickly. We want what? Yeah, we want the time, but not just the time. Yeah, we want the total time. Exactly. We want the total time. So let's go ahead and highlight that. What is the total time taken for the trip? So everyone, if we're trying to find the total time, like we talked about in our notes here, if we're trying to find the total time taken for an entire trip, what are we trying to do? Yeah, we're going to be adding. We're going to be adding the time for the first part of the trip and then the time for the next part of the trip. Everybody, before I continue, do we remember that from the notes that we just took? If we're trying to find the total time for a trip, we want to add the first part's time and the second part's time. If there's a third part, find the time for the third part, right? Now, even if we know that like the back of our hand, if we want to get the total time and we're saying, hey, get the first time plus the second time, everybody, what's the problem? Do we see that we're given the time anywhere? Does it say time explicitly anywhere? No, I don't see it either, right? I don't see it. I see a race car drives 63 miles at 21 miles per hour. That's funny for a race car. And then drives 56 miles at 14 miles per hour. I don't see time given to me anywhere. But, my party people, but let me highlight this in green. 63 miles, that's a distance. 21 miles per hour, that's a rate. Everybody, if I have a distance and a rate, what operation am I doing to find the time again? What operation am I doing? Yeah, we're dividing. We're dividing. Remember that if I want to find the time, I'm going to have to move the rate over by dividing it out. Let's go ahead and just remind ourselves what that looks like when I plug my numbers in. Let me plug in the miles, 63 miles right here. Let me plug in the rate, 21 miles per hour. And I'm looking for that time. So notice that if I'm trying to get the time by itself, I got to get rid of that 21. So let's divide by that 21 on both sides here. Everybody, how many times does 21 go into 63? Yeah, that's going to be 3 times. And so with that, again, 63 divided by 21, that's going to be 3. That cancels out on the right, and we're going to have t equals 3 hours. Now, everybody, is the answer going to be 3? Is that it? Are we done? Are we done? No, we're not. Because all we did was find the first time. That's all we did. We just found the time for the first part of the trip. That's all we did. Then up next, everybody, we see that we have 56 miles at 14 miles per hour. Let's highlight that here in blue. Let's find that second time. So if I do that over here, we're going to have distance equals rate times time. And I'm given 56 miles. So that's my distance right here. That's my distance, 56. I'm also given the rate, which is 14. And then we are multiplying by the time, which is what we're trying to find. And so again, we're going to be dividing. Same thing again. We're going to be dividing here. So let's divide. We have right over here, let's grab black, divide by 14, divide by 14, and that's going to cancel out on the right. Now, for those of us that are feeling a little apprehensive about dividing 56 by 14, remember everybody, what we can do is we can go ahead and simplify first. Everybody, what's that? What's a big number that goes into both 56 and 14? Because if you don't know what 14 going into 56 is, that's fine. But how many times does, 7. Everybody, how many times does 7 go into 56? Let's do that. I can divide 7 out of both. I can simplify first. Because if I do that, guess what this turns into? This turns into 56 divided by 7, that's 8. 14 divided by 7, that's 2. That's way easier, right? That's way easier than trying to do 56 divided by 14 in your head. Way easier. 8 divided by 2, everybody, what's that? Yep, that's going to be 4. Appreciate y'all, and we're good. The time here for the second leg of the trip is 4 hours. So now that we have that, now that we have 3 hours for the first leg, 4 hours for the second leg, everybody, what did we say we were going to do? Exactly, Giovanni. We said we were going to add. We're going to add to get the total time. So 3 hours plus 4 hours, that's what's going to give us the 7 total hours. And there we go. Now, I'll be very clear here. I know some of us believed that we were supposed to do 21 minus 14, but that is incorrect. That gives us, think about it like this. Let me actually just highlight the right answer, D, 7 hours, because we found it right there. But let me show you why the coincidence is going to be wrong. Everybody, we're looking for hours. We're looking for hours. If we were to just say 21 minus 14, yeah, that's 7. I'll give you that. But it's miles per hour, 7 miles per hour. That wouldn't justify 7 hours. So that would have given you pause. It should give you pause because it's not even the right unit. So I want to make sure that, yes, coincidentally, that would have given you the answer, but it's always the reasons why. We want to learn how to repeat that success. And if we're doing something that's wrong, but coincidentally right, I wouldn't say that that's something you should learn from, because we got lucky and that's all that was. Now, party people, does that make sense? Not only the right way to do it, but why the wrong way was wrong. Cool. Sounds good. Sounds good. Now, so can I explain? So Johnny, can I explain where I got the division by 7 or the simplification? Oh yeah, for sure. Yeah. So when it comes to the simplification, so this is a fraction right over here, right? 56 divided by 14. So what we just did here was we said, hey, look, 56 divided by 14, I don't know what that is off the top of my head. And if I try to do long division, I'm still going to be guessing anyway, because you don't know how many times 14 goes into 56. So what I opted for instead was, well, this is a fraction. And if I can simplify it, again, make the numbers simpler to deal with, I'm going to have a better time. So I recognized that 7 can go into 14 and 7 can go into 56. So if you've heard the phrase before, whatever you do on the top, you do to the bottom, that's exactly what I did. I divided both the top and the bottom by 7 because it's going to keep the same answer. It's going to keep the same value. It's just going to simplify it to 8 divided by 2. 56 divided by 14, same thing as 8 divided by 2. But we were able to make it look easier to actually get that number. So let me know if that makes a little more sense there in terms of simplifying fractions, but that's something you want to familiarize yourself very well with. Yeah, common denominators, for sure. Cool, I'm glad that makes sense. So with that said, yeah, it's definitely something you want to learn for sure, for sure. So with that, I am going to move it over here to the next problem. Are we ready to try another one out? And again, it could be one that we've seen in terms of the situation, or it could be something completely different. Are we ready? And let's give this next one a shot. So, my party people, the first thing we always do is read that question. So when we read the question, what is it that we're trying to find? What is the driver's average rate for the entire trip? What are we trying to do again? Yeah, we're trying to get that rate, of course. So what is the driver's average rate for the entire trip? Okay, so everybody, what did we say? When we're trying to find the distance for the entire trip, we add everything up. When we're trying to find the time for the entire trip, we add up all the times. However, what did we say we need to do when we are trying to find the average rate for the entire trip? Correct. We want to divide. And specifically, let me go ahead and shout out who said that. Reggie, we want to divide the entire distance by the entire time. Great job, Reggie. So, yep, with that said, if I'm writing this down right here, so we're trying to do the rate for the entire trip. We want to take the entire distance and we want to divide that by the entire time. That's how you get the rate for the entire trip. So with that, we're here. Let's get that entire distance, everybody. Let's read and see what we have. A driver travels 40 miles and then 80 miles. The total time for the trip is 4 hours. So look at that. We have the entire trip. Total time for the trip, 4 hours. So we have that already. So we're good. Let me just write that right there, 4 hours. But then that total distance, everybody, yeah, that's going to be the 40 miles plus, right here, the 80 miles. So if we do 40 plus the 80, yeah, that's going to give us 120. Exactly. That'll give us 120 miles. So now that we have the entire distance and the entire time, we're set to divide nice and easy. Everybody, what is 120 divided by 4? Correct. That'll give us 30, and that's the rate. So that would end up being 30 miles per hour. And there we are, my party people. And the answer is C. Boom. So who here is feeling that confidence continuing to come up, rising slowly but surely through the mistakes, through the successes? Because remember, it's not about getting lucky. We want to repeat that success. It's not about being wrong. It's about understanding the reasons why we're wrong. If we can continue adopting that, this is going to continue getting better and better and better. Regardless of what methods you use to study, it's about how you go about studying that really makes a difference. So really proud of y'all so far, man. Really proud of y'all. So let's go ahead and move it over to the next question. Let's keep it going. We're doing a great job. And I also want to remind everybody that, again, this is part 1 of 2. Has anybody here ever done a question where you had not legs of a trip or going north and south, but having 2 rates at the same exact time? Who's had questions like those? Yeah. So if you've taken a practice test of the real deal, those are one of the staples that you'll see when it comes to distance, rate, and time. Dealing with 2 objects moving at the same exact time. And if you can handle those, distance, rate, and time is going to be a breeze. Promised. So with that, that's what tomorrow's class, a little preview of tomorrow's class, but let's keep sticking to it here. Let's keep doing a great job. Here is the next one. We are going to move the timer down to 2 minutes for these next couple. Remember, we are not trying to get the right answer in the 2 minutes. We're just trying to get the right process, get the right plan in 2 minutes. So here's the next one, starting now. And let's try it out. So first things first, as always, everybody, we want to know what the goal is. In this particular question, what's the goal? Yep, total distance. What is the total distance traveled? So this one would be a relatively quick one because we see here, if we're trying to find the total distance, well, we might have one distance one way, another distance another, and we want to just add it together to get the total distance. So with that, we see that we have a kayaker paddles for 3 hours at 4 miles an hour, and then for 2 hours at 5 miles per hour. So let's write that down and highlight it. So 3 hours at 4 miles an hour, that's the first distance. So first distance is going to be 4 miles an hour multiplied by 3 hours. And then we are going to have our second distance, 2 hours over here. Let me grab the green highlighter. 2 hours at 5 miles per hour. So I'll write that down over here for the second distance. 5 miles per hour multiplied by 2 hours. And that's it. Because to get the total distance, even though they didn't give me the individual distances, we're more than welcome to find the first distance, find the second distance, and then we're good. So the first distance is going to be 4 times 3, which is 12 miles. And then the second distance is going to be 5 times 2, which is 10 miles. And there we are, my party people. There we go. We have our first and second distance. We can write that down right over here. Fill in what we have, 12 plus 10. And that's going to give us a total distance of 22 miles. And there we are, my party people. Answer here is B. Now, Even though the numbers felt straightforward, right? Single digit numbers. Who here is truly starting to break through the numbers and see the processes, the reasons why we're making the decisions that we're making? Because that's really what's going to spell success. Knowing the process and justifying why you're taking the steps you're taking. That's how it's always going to be. Hey, there we go, everybody. So it looks like we have time for one more problem. Are we ready to go? Hey, right on. Here we go. Let's go ahead and get over to the next problem here in 3, 2, and 1. So as always, first things first, what is it that we're looking for? It's the first thing. Yeah, we want to know that question, and it says right here, what is the driver's average rate for the entire trip? Sounds good. So let's highlight that right there. What is the driver's average rate for the entire trip? Cool. So when we're looking for average rate, everybody, are we trying to add the rates, or is there a different process? Help me out again. Yeah, we are going to divide. Remember, we're going to be dividing the entire distance by the entire time. Exactly. Entire distance by entire time. So if we're looking for that average rate, we need the entire distance we traveled by the entire time it took us to travel that distance. So total distance divided by total time. All right, perfect. So with that, let's go ahead and get that done. We see that the entire trip here takes 4 hours. So we can go ahead and write that 4 right there on the bottom, no problem. But then when it comes to that total distance, we see that we have a couple of legs, 55 miles and then 85 miles. So with that, right here, let's highlight that in blue. So if we have 55 plus 85, what's that going to give us? Yep, that'll be 140. 5 plus 5 is 10. Carry the 1. 5 plus 8, that's going to be 13. Carry the 1 is 14. And so we'll have 140 divided by 4. Now, there are 2 ways that we can do this with a little bit of mental math. We can say, hey, 140 divided by 4. We can divide by 2 and then by 2 again, because dividing by 2 twice, that's the same thing as dividing by 4. So that'll be 70, and then 70 divided by 2, that'll be 35. But if you didn't know that, I can't blame you, right? I can't blame you at all. If you didn't know that, no worries. We can go ahead and just do some long division. 4 going into 140. And we'll have 4 goes into 1. It doesn't. 4 goes into 14 3 times. 3 times 4, that'll be 12, giving us 2 left over. And after we drop that 0 that's right there, we have 4 going into 20, and that will be 5 times. And so there we go. We have 4 goes into 140, 35 times. Let me zoom on out here, and that'll be 35 miles per hour. And that's why here the correct answer is D, 35 miles an hour. And that's it, my party people. You have now gone through the fundamentals, the essentials for distance, rate, time. So I don't want you feeling too safe, because yes, this is great if we're feeling like we are truly feeling confident with the fundamentals, but that means that you are ready to start handling those moderate and challenging test level questions. Now, think about what you were able to accomplish here in this 2-hour session and what you could accomplish now that you have the fundamentals set, making those hard questions easier than they were before. Are we excited for that next session coming up?